Alright, so we've discussed quite a few plots by now. We've discussed line plot, the bar plot, and the pie plot. And there still are a ton more we could have done. We could have done contour, we could have done scatter plot. But I think it's time to up our game now. You know, it's time to go into the big leagues. We've done enough of the minors. It's time to go big. So we're finally going to be talking about 3D plots. I know. It is amazing. The 3D plots, what you can do with them, it's quite cool. Very cool, actually. And I'll be showing you in the following few lectures how to create some pretty awesome 3D plots, what you can do with them, stuff like that. So let's get started. With 3D plots, it is a slightly bit different with the code. We'll be doing something similar, but one or two things might stand out to you. The first thing that might stand out is the import. So what we have to do is we're going to say from mpl underscore toolkits dot mplmplot 3D. You're going to import axes 3D, and this basically allows us to create those 3D plots. And then the second one's going to be the exact same thing. Import matplotlib dot pyplot as plt. Fig is equal to plt dot figure. And then ax is equal to fig.add subplot 1, 1, 1, and then you're gonna say projection equal to 3D. So let me quickly explain what's happening. Figure is equal to plt.figure. You guys already know what's happening, okay? We're creating a figure just like we did while creating multiple graphs, and this is ax basically stands for axes. You can say chart. Chart sounds easier. Excuse me. Chart is equal to fig.add subplot. We're just adding a subplot 1, 1, 1. It's 1 by 1 dimension, chart number 1. And projection equal to 3D basically tells our matplotlib module that, hey, this chart is going to be 3D, okay? So if you don't know what a 3D plot is, let me quickly explain to you. It's not at all hard. Basically, it involves the z-axis, so it's actually quite cool. Over here, this is our normal 2D plot. Yes or no? Yes. The way 3D works is it's sort of like a cube. So think of this as a cube. Horrible drawing, I know, but it works. This is our cube, okay? You have our dashed line over here, and you have the dashed line over here. So this is a 3D cube. This would be our x-axis, this would be our y-axis, and this is our z-axis. So up is z, right is x, and straight is y. It's a little bit complicated, but you know, it's very interesting. So you have x, y, and z, where z is basically a third dimension, okay? And that's what we have to create. So go ahead, say x, comma y, comma z. We're gonna use multiple declaration over here. X, comma y, comma z is equal to 1 array, 2 array, 3 array. So what's x gonna be? X, again, so remember, the number of points you use for x, you have to use the same number of points for y and z. If you create 10 points for x, you need to create 10 points for y and z as well, otherwise an error will occur. So we have x, y, and z. I'm gonna go ahead and write some random points. First, 1, 2, 3, 4, 5, 6, 7, 8. For y, I'll do 2, 5, 3, 8, 9, 5, 6. Someone is that 3, 6, 7, and let's do 1. And then for the z, so this is our third dimension, I'll do 3, 6, 2, 7, 5, 4, 5, 6. Again, I honestly have no clue what I'm typing because I can't think that far into the third dimension, but I understood what I was doing when I was typing the y. Anyways, x, y, z is equal to these 3 arrays. You can do whatever values you want. It doesn't really matter. The end product matters, and that's really what we care about. And now we have to plot these. So the plotting will be, again, a little bit similar. So it's going to be chart.plot, and we've used this function before, except chart.plot underscore wireframe. And we're using the wireframe to specify that we're plotting a 3D object. Okay? So now just go ahead and put in x, comma y, comma z. So that basically says we're plotting a 3D object. Here are the 3 coordinates. And now all we have to do is say plt.show. Save this, F5, and ta-da! Okay, I said that a bit too early. Wait. Okay, we have the restart thing. Here comes the Python launcher. Ta-da! So this is our 3D module. Okay, this is our 3D diagram. This is actually really cool. You can go ahead, spin it around, take a look at what we just created. The way you want to look at it is this is our x-axis, or let me see. What did we create? Yeah, I think so. So this is our x. Maybe this might be our y. This is our z. Yeah, whichever has 9. Did y have 9? Yeah, okay. So this 1 through 8 is our x. This is our y, and this is our z, the one that's going straight up. So you can sort of correlate. I mean, let's take a look at the first. So x was 1, y was let me take a look actually. So y was 2 and z was 3. So 1, if you look at it from totally at the top, you can see that y is equal to 2. And if you look at it from the 3D perspective, you can see that z is equal to 3. So again, it is a bit complicated, but 3D modules have, or 3D graphics do have quite a lot of popularity in gaming and stuff, but we have created our very own 3D module. Now, another thing is, if you wanted to, like, you know, say the PNG of this and stuff, it looks bad right now. You have all this gray space. So what I'd suggest is make this go up a bit. Sorry about that, guys. Been talking for a long time, that's why. But what I do is I go ahead and change the left to make it all the way to the left, bottom all the way bottom, right all the way to the right, and top all the way to the top. And the reason I'm doing this is because at the end of the day, it just gives it a better look, a better feel. You know, you have white space all around, and you know, it's a much more cleaner view than having that gray stuff around. Anyways, awesome job, guys. You've just created your first 3D graphic. Again, if you're not sure what I'm doing, you're supposed to select with your left mouse and you drag. So select, drag, select, drag. Anyways, awesome job, guys. This is again our first 3D module or 3D graphic, and I'll see you in the next lecture.